Well, this talk is going to be in English, so there's just wait 1 more minute. I'm very bad telling jokes, and I'm especially very bad telling jokes in English, so I'm not going to tell a joke. You can try if you want. This is a serverless talk, so maybe joke about Kubernetes or something like that. Could be fine. No offense, no offense. Okay, it's time, so let's start. It's my first time giving a talk in a cinema, so that could be fine. Cool. Well, my name is Vicenc Garcia. I'm now in a kind of weird situation because I live in London for the last 5 years, but now I'm working for a company called Voxel, which is based in Barcelona. No? So usually people do the other way around. So they live where you can see the sun and eat well and cheap, and then you work for a company where there's more money. But I'm doing the other way around. So let's see how it works. My only hope here is that in a couple of years, between Brexit and climate change, London will be a warm city with a crappy economy. So that would be perfect. Yeah, I'm pretty sure about the crappy economy. Not that sure about the being a warm city. Well, as I said, I work for a very nice company called Voxel. They do like B2B payments, especially in the tourism industry. I work there as what we call technical coach. Coach because it's a trendy word, and if you put coach in your CV, you get lots of calls from recruiters by LinkedIn, and we all love being called by recruiters. Not really. And technical because I help them to try to program a little bit more better. I was hired just for the programming part, but I'm also I also like the part of operational and helping them in working better in general. And those are my contact details. If you want to ask me anything or whatever, just drop me an email and I will answer the best I can. Well, in London, in the last, so some of my last projects were from the retail industry, which I think it's a nice industry for many reasons. One of them is that it's usually a big company, so they have money, which is always a good thing to have. The second is that they are usually quite old companies. The last one was 30 years old, and the previous one a bit older even. And that means that they have a lot of legacy code, and I love legacy code, and I love trying to improve the legacy code, because legacy code is code that gives you money, so let's respect legacy code. And the third one is that because they usually have a kind of monster that tries to eat not only their piece of the cake, but the whole cake, the plate, the cutlery, the table, their house, everything. And that's Amazon. So when you work there, you are in a company that needs to improve and needs to deliver new things, and they have money to do that. They have the motivation to do that. So it's a kind of, it's nice, and it's the heaven for a contractor. And my last job was for a fashion company. I was in a kind of pre-operations team, so we take third-party software, we install in some machines, we install other software on our own script as well, and then we package everything, we create an image, and then we deliver to the stores where they install the software in the stores, now in a kind of manual way. I was like 270 stores and 2,000 devices. And that third-party software had some problems. The first one is that it has books, as you can see. And fortunately, those books that didn't impact the users. The users or the clients could buy some clothes and return the clothes and so on, but impacted the operations team because some of these transactions get stuck somewhere, or they come to us with a value of 0, and we have to reconcile everything, or some services stopped with no reason. And that what sounds scary is not the creepiest part of the project. For me, the worst part of the project is that we didn't see anything. So we only notice these things when someone calls us and say, hey, we have a problem. I remember a meeting with those guys, and I asked, well, I'm going to install your thing in 2,000 devices, so I want to create some dashboards, some alerts, some alarms, something like that. And they say, well, this alarm thing, yeah, we don't really have anything. I say, whoa. And I ended up spending most of my time there creating some scripts, some program to go to the local database of each of the devices, get some data from there, and try to make some calculations to see if everything goes well. And that's not an ideal situation. You don't want your business as usual to be a nightmare or to be an adventure. You don't want to feel like Indiana Jones or Lara Croft every day. You want to your business as usual to be kind of boring, and you want to spend your brain and your energy in the most interesting things. And this that applies to software also applies to the platform you choose or the technology you choose to develop your project. If you choose something that is not mature enough, you can have some nasty problems in production that you don't want to have. And that's what we're trying to see today, if serverless is mature enough to use. So what's serverless? I like this definition from Simon Worley. It says use serverless as an event-driven, utility-based, stateless code execution environment. I don't know if you know Simon Worley. He's a kind of IT guru, at least in UK. And he's the creator of the Worley maps, that kind of think now. And he also writes these very, very long threads on Twitter when he's talking to someone and answering very smart things. And this is one of these threads. So what that means, event-driven means that the execution of code is triggered by some event. Utility is that you only pay for what you use. So if you don't use anything, you don't pay. You pay nothing, which is great. Stateless is that no state is kept between invocations. At least in Lambda, this is not entirely true, but you cannot rely on that. So let's say that it's stateless for us. And code execution is you only care about your code. You don't care about the machines, about OSs, about patching, about anything. Just your beautiful code. And this is another kind of definition from Danilo Poccia, which is the principal serverless evangelist at AWS. I don't really like this word evangelist but yeah, big companies you try. No? They feel like God, I guess, and then our workers are evangelists. So as you can see, you have some fully managed services. When you're in the kind of serverless mindset, you like fully managed services because you don't have to, but basically you have to care about that and just use them. And these fully managed services raises some events. That could be whatever. A user uploads a picture, some API calls you, whatever. And then that triggers a function, which is where your unique business logic resides. And eventually, this function can work with these fully managed services again. And this is a thing that at some time will stop, obviously. So this was fun like 3 years ago, but this kind of joke, but why do you call it serverless if there are no services? Okay, yeah, that was fun. That's no longer fun now. Obviously, there are servers there, but the thing is that you don't care about that. No? An example is that last year, AWS open sourced the technology behind serverless, which is this firecracker thing, I think it's called. And it's a very nice kind of containerization technology. They raised a new container in 20 milliseconds or something like that. It's very fast, it's very nice, but I don't really care. I don't want to know what's behind my Lambda. I just want to write code that executes the fast it can. And yeah, this is the Gartner hype cycle for emerging technologies of 2017. I checked the ones of 2018 and 2019, and Serverless doesn't appear there. I guess it's not longer emerging. Serverless is that arrow there. These guys separate the graph in 5 sections, and in 2017, Serverless was in the innovation trigger. And they reckon that in 2 to 5 years, so between 2019 and 2022, Serverless was in the plateau of productivity. So in this talk, we are going to talk about that and see if we are in this plateau of productivity or not. And, oh, I had another thing here. Well, yeah. Another thing that you can check if you trust more ThoughtWorks than Gartner. I work for ThoughtWorks, so I trust more ThoughtWorks. And Serverless appears as a blip in 2016 and a blip again in 2017. So, and they said that you can use it, you should use it if you can. So those are my biases because the technologies I work with. I work with Azure Functions and .NET Core. The philosophy of Azure is a bit different about serverless. We can talk that afterwards, but I'm going to concentrate in AWS with Node.js and with the serverless framework. And do you remember when DevOps was something more than just a word used by recruiters and project managers to talk about the systems guys that knows to write some Terraform scripts? Yeah, me neither, but it was. Actually, I have a friend that called that DevOps is agile well done. Edu Ferro, if you know it, you know him. And well, those are 2 of my favorite books. One of is the follow-up of the other. And in the Phoenix project, we follow the adventures of Bill Palmer, which is has recently promoted to VP of IT in a company called Parcel Limited, which is a big manufacturer and retail company. And they have their most important project there, which is the Phoenix project, is a very high risk. And what happens is it's the usual blaming culture, conflict between requirements and firefighting, political issues, people over pressure, not real management, etc. I guess most of us have worked in this kind of project sometime. But Bill meets a future member of the board, who explains him the 3 ways. We're going to talk more about these 3 ways in a minute. And in the DevOps handbook, that, as we said, is a kind of follow-up. Actually, they are writing the second part of the Phoenix project right now, so it will be off someday. And the DevOps handbook, they go deeper to this, especially to the technical practices of these 3 ways. So which are those 3 ways? The first one is the principles of flow, that emphasizes the performance of the entire system as opposed to the performance of just a silo or a department. So they focus on the business value streams that are enabled by IT. The second one is the principles of feedback, which is about creating the right to left feedback loops and shorten or amplify them. And the third one, if that works, yeah, is the principles of continuous learning and investigation, which is about creating a culture that fosters continual experimentation and understanding that repetition and practice are prerequisites of mastery. That sounds good. So let's talk about the technical practices of these 3 ways and see if we can follow them using serverless. And the first one is the technical principles of flow. As we said, our goal is to create the technical practices and architecture required to enable and sustain fast flow from product, from development to operations, without causing any trouble to the production environment or to our customers. So we have to be able to reduce the risk associated with deploying and releasing changes into production. We're going to focus on 4 things and see how Serverless applies them. The first one is unit testing, fast and reliable testing. So we want to catch these guys. And obviously, testing is a good thing. I hope I don't have to convince you that you should unit test and integrate test and do lots of tests with your software. And we should do the same with serverless. But serverless is a bit different. So our functions tend to be small, and we have more integration than maybe in other architectures. So the difference here is that we might give more importance to integration testing than in other architectures. We can do unit testing as usual. If you follow hexagonal architecture inside your functions, you can replace your adapters with some mocks or spies or whatever you need, and then unit test your local your code inside the function without any problem. If you prefer to mock directly AWS services, you can also do that. Although maybe it's not super recommended to do it. And then you move to integration testing, which you cannot local test that. A usual thing to do while developing on serverless is just to deploy solution and integration and do the integration tests in the cloud, directly in the cloud, or you can run your function locally and then but using the services in the cloud. At the end, your function is a function, so you can call it with the right parameters, and it has to work. And we'll talk more about this later, but you can isolate your testing environments from your partners and from the real environments on the company with ease. Hopefully, you don't work alone in your project, so at the end you have to do some integration and some continuous integration. And we're not going to talk about trunk-based development or feature rented or these kind of things. It's something we can discuss with a beer as well, or with a Coke or water. And yeah, you have to integrate and run this test also in your continuous integration machine. And as we talked before, we should create a new environment for this stage and run our test there. And you can do this easily with serverless. So we'll cover them. And then the next point is to create the foundations of our deployment pipeline. And that's interesting. We always must ensure that we use production-like environments in all of the stages that we use. And that means that we should recreate these environments for what we have in our source code and our configuration system. So you should be able to recreate your whole environment like in a self-service way, just clicking a button or whatever. I hope you do this in your current project as well. It's not just a serverless thing, it's just a kind of generic thing. And these include 4 steps. Enable on-demand creation of dev, test, and prod environments, as we already talked about. Creating environments on serverless it's quite easy and it's quite cheap. And depending on the services they use, it's free. More than cheap, it's free. Create our single repository of truth for the entire system. We can have our configuration script, our infamous YAML on our source code, so it should be fine. Make our infrastructure easier to rebuild and to repair, and that's absolutely true. And finally, modify our definition of development done to include running in production-like environments. As we said, it's quite easy to create the environment, so we can run everything there. And it's not that it's easy to create environments, but it's difficult to test locally. So at the end, you have to test in the cloud. So as we said, we are talking about creating environments. So what options do we have? The first one is CloudFormation. I don't know if you have worked with CloudFormation, but this very, 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 very long JSON file. If you work with Azure, is something very similar to the IRM templates, which are kind of nightmare. And this is like the bytecode of the infrastructure in AWS. No? So everything compiles to CloudFormation, and then Amazon takes care of it. Yeah, if you can write your own CloudFormation if you have a lot of time. The second thing is Terraform. I don't know if Yeah, maybe. Yeah, maybe Wi-Fi is not working properly. This should be an icon of Terraform. So Terraform also it's a tool to create environments. It's cloud agnostic in the sense that you can use it to create environments on Azure, on AWS, on cloud, on Google Cloud or whatever. It's not cloud agnostic in the sense of that you can reuse the scripts that you use in AWS to create things in Azure. They're completely different. And at the end, it creates CloudFormation as well. You have to write less, and you have to learn a new kind of language. Yeah, the next one is the serverless framework. These are serverless specific tools. Serverless framework is probably one of the first frameworks that appear kind of 3-4 years ago. And it's very used. They have a big community and a lot of plugins. They're very fast incorporating new things. For example, I think 2 days ago, Amazon released a new thing that you can specify the size of the batch when you read a message from SQS, I think. And yesterday they already implemented in serverless framework, so it's quite not SQS in Dynamo streams. And so they're very fast. And you have to write a YAML, and it works very well. And now they have a kind of enterprise solution as well. I haven't tried that, but you can do more things. It's my favorite framework. Yeah, no images today. There's SAM. SAM is a kind of the same thing as serverless framework, but done by AWS. And it's more or less the same. You define in a kind of CloudFormation style thingy your file, your infrastructure, and it takes care of it. It helps you testing locally things like API gateway that you cannot do in the serverless framework. I guess they are working on it, a lot of it, with it. And I guess they try to make people use it, like all these big companies. And some things more, I'd say, less used or strange or different. It's a pity that we cannot see the images. Sorry about that. One of them is Pulumi, and the nice thing about Pulumi is that it's, or nice or well, there are people that like it and people that don't like it. But is that you write like real code, no? So you have kind of safety. There are people doing Pulumi with F#, which is, and it's very nice. The shape of the script at the end, and it's type safe and everything. So it's quite nice. Next one is Stackery. Stackery, what it does is so you define your architecture in a kind of visual way. So you define this function will talk with this SNS topic, and this function will receive the SNS topic, and will do some things, and blah, blah. And then it kind of creates a template for you where you can write the code of your function in a GitHub repository. They have also some very interesting tools for local testing. Next one, it's something that got the first release like 2 or 3 months ago, which is the AWS Cloud Development Kit. It's not serverless specific, but it's you can do whatever you want inside AWS, and it's like Pulumi, so it's something that you can develop. I think it's now with JavaScript, Python, and Java, I think, if I'm not mistaken. Also, if you use Java, it will be type safe and so on. And there are other tools. You have to consider that this is a kind of mixture of a new thing with a lot of people using JavaScript, so this can explode, and we have frameworks like every 2 days we have a new framework. Those are one of the most used, like Chalice, Apex. Apex, I think, is the one that allows you to use Go. Architect Claudia.js, the one from Goico Ajax, Sparta Zappa, one of them is the one from PHP. lot of frameworks. And the last thing is there was a canary here, enable and automate low-risk releases. And what do you try to have? So AWS gives you blue-green deployments by default. So you, if the deployment of your lambda, the new version of your lambda doesn't work well, it rollbacks and it doesn't, you don't get the new version. But if you want to do canary deployments, there are some limitations. So there are not a lot of options of the traffic that you can route, and you can only route traffic. You cannot route users. So if a user can have the two versions in two subsequent calls, you cannot propagate routing decisions to your downstream services. So this can cause many problems, and the metrics are not tracked against versions. So you can have kind of a mixture that can raise unnecessary rollbacks and so on. So it's not the best thing right now. And the alternatives, well, you can have client-side routing, or you can use other tools like Launch Darkly, which is a very used tool for feature branches. It's not perfect for canary deployments, but you can do something. And then let's move to the second way, which is the technical practices of feedback. What do we want is to enable fast and continuous feedback from operations to development, so we can respond to problems faster, and we can anticipate things, and we can learn how our users are using our software, and take product decisions as fast as we can. The key concept here, and it's being a trendy concept in the last few years, is observability. I think 2 years ago there was a track on the QCon just for observability, and you have a very nice keynote at the end of the day from List and from Honeycomb, which we are going to talk about a little bit. And the engineering team at Twitter has been talking about it since 2013, and they talk in a blog post in 2016. They talk about 4 things that you have to do, which is monitoring, alerting and visualization, distributed system tracing infrastructure, and log aggregation. In serverless, we have some challenges to do that. The first one is that we don't have access to the underlying infrastructure because AWS takes care of it. So we cannot just put a daemon or something in the container because we don't have access to the container. So that can be a problem. The second one is timing. So when you're doing functions as a services, everything goes, you have to do everything inside the function, inside the vocation of the function, unless AWS does the thing for you, like we will see later with CloudWatch and X-Ray. But if you're doing something different, this will go to your function duration, and this can impact not only your user, but can impact your bill, because if you're taking more time, you will pay more. And now concurrency is managed by the platform, not by you. So at the end, you can have like a lot of concurrent invocations of your function. So if you want to batch this monitoring or this data, you will be less performant. And the platform can just tear down or garbage collect your container whenever it considers necessary. So you can have batched a lot of data, and then when you try to send the data, the container got garbage collected, and you cannot send the data. And there are some platform limitations. CloudWatch have some limitations, and X-Ray have some limitations as well. So maybe it's not the best thing to use, and we'll talk about that today. So right now, sorry. So what AWS offers AWS offers CloudWatch for logs and X-Ray for traces. So whenever you write something to std_out, and that in JavaScript is a console log, that goes automatically to CloudWatch without impacting the timing of your function. So you can write as many console logs as you want. And then for a given invocation, for a given function, that log appear in the same log group, organizing a log stream for each concurrent invocation of the version of the lambda. So at the end, you have a log group with a lot of streams, and you have to, and if you have to search something, there can be big cumbersome. Lately, they are improving that, and you now have a kind of SQL-like language inside CloudWatch to search inside the logs. It's kind of very manual. You have to select the logs that you want to, the log groups you want to make the search, and then make the search. You have to learn this new language and so on. So it's not. I think it's not still in a super nice place. And if you want to overcome this limitation, you have kind of two options. The one is you can stream logs to different things. You can stream logs to the managed Elasticsearch from Amazon, which people doesn't like too much. And you can stream logs to a lambda function or a Kinesis stream. And after that, you can then send these logs to your preferred log aggregation platform, no? Which is, I think it's what most of the people do. And then X-Ray provides some basic tracing that you can extend. And they are improving the services that are included in X-Ray, but there are still some limitations, so you won't see your whole architecture there. So what other solutions there are here? So as we said, we can stream our logs to another platform. So here you can use Splunk if you have enough money, or Logs.io, or your Elasticsearch, or Honeycomb, which Liz will explain how it works. You can do whatever. In my first job, we streamed to Splunk because the company was paying for that, and I've been doing work with Logs.io as well, so it's perfectly fun. And then are several specific solutions, as you cannot see, but they're there. And there are 4 main solutions there, which is Thundra, IOPipe, I don't remember the name of the third one, and Epsagon. I've worked a little bit with Epsagon, and it's a nice solution. It's very easy to incorporate it in your code, and then you can see all the traces and all the metrics and the cold stars, the whole architecture of your system, and you can set alarms, everything. So it's a very nice monitoring, alerting solution. And finally, let's talk about technical practices, continuous learning, and investigation and experimentation. As a team, as a company, we need to create opportunities for learning as quick, frequently, cheaply, and soon as possible. And this includes creating learnings from accidents and failures, as well as organizing our systems of work so that we're constantly experimenting and learning from failures. And that can include many things. So you can do, if you look at the DevOps handbook, you can do game days, which are nice, and you can do, we're talking about the other day in Twitter, this thing of chaos engineering for teams. So you can choose a team member and say, tomorrow you're not going to be, so you're on vacation, and then see what happens to the team. Or you can do blameless postmortems, which is a very nice tool. Or you can inject failures on your system, which is what we're going to talk about today. This chaos engineering. Netflix has popularized the principles of chaos engineering. As it happens with serverless, maybe the name is a bit misleading, but at least they have chosen a kind of funny name. So They had no jokes about the name, I think. The definition, the original definition of chaos engineering, and let me read, is chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. I like the word turbulent conditions in production when nothing works. But it's not about breaking production. See, what happens is about building confidence in your system. So you are testing what happens when something bad happens. But this is not very sellable to your management. No? Russ Miles is a guy that I think it's actually writing a book about chaos engineering, and he has a lot of articles about that. And what he doesn't like is the name. No? So you cannot go to your management and say, hey, I'm going to break production and see what happens. This is what Netflix does. This is fantastic. And probably your boss will say, no, please. And that's not a good... It's not a good situation where you can ask for forgiveness instead of permission. So if you break production, you can cause a lot of troubles. So what Russ proposed is this definition, which is limited scope continuous disaster recovery. Why? Because you should have a disaster recovery system in your company. Hopefully you have, and do you test it, and do you work with it some days and so on. I am sure that you do that. Limited scope, that means that you basically you don't break everything. No? You just test a little part of your system. What happens if we inject an error here? And finally, this should be continuous. You should do this in a continuous manner. If you can do it in your CI or in a special build of your system, or nightly build or whatever, that would be fine. But serverless brings new challenges to Chaos Monkey. Because we cannot tear down, for example, a container because you don't have access to the platform, so you can just not do that. But we have some actionable failure modes that we can work on. First is improperly tuned timeout, so you can inject a timeout in your calls and see what happens if the caller are prepared for these bigger timeouts. You have to control this missing error handling, so you can inject some errors on your functions or your errors in the configuration. Remember that now with serverless you have much more functions, so you have much more configuration and configuration for each function. So it's good to test configuration. So that can be a good thing to do. And finally, you can tear down a downstream service and see what happens to the caller as well. So you can do some things. And there are two tools, which is one is Thundra, is the same that we talk about observability, that has a library to inject these kind of things. And the other one is Chaos Toolkit. There should be a logo here, Chaos Toolkit, that you can do basically the same. You can inject some errors and latency to your functions. And finally, I have 2 minutes. Security, there's basically a company that are doing a lot of things in security, which is PureSec. They have some open source library which detects, for example, if your function is calling some external HTTP or doing some external HTTP call, and then it can alert you that, hey, you have someone in your code is trying to make an HTTP call. Maybe you shouldn't do that. And PureSec as well has a platform that you can integrate in your CI system, and it can analyze your code when you commit your code, when you build, and when you run your code. So in summary, I think we are in a kind of very good situation. I think testing is you can do good testing, you can implement a continuous integration delivery pipeline, you can do good observability, and you can do chaos engineering. And they have to work a little bit more on low-risk releases, basically on canary releases. It's something to improve. I was talking with a friend of mine today, and they have kind of the same problem using Kafka, which it looks like I haven't worked with Kafka, but he said that it's kind of difficult to canary releases with Kafka, so we're not that bad. So this should be a logo and an approved marker. So I think that we can securely use serverless in our production projects. Oh yeah, I'm giving a course about serverless. Next edition is tomorrow. If you don't have time, I'm giving another one at the end of October in Barcelona. So send me an email if you're interested. And thank you very much.
Thank you.
There's any question?
Yes.
You can ask in Spanish if you want, and I will do the translation if needed.
No?
Not difficult, it's quite late.
Can you briefly compare Azure to AWS, like highlights?
Yeah. So first I'm going to guess, and then I'm going to explain you my guesses. So what I guess is that, so AWS come in 2014. That's the year that Frozen came along as well, in case you have kids. And then my guess is that Microsoft took a look at Lambda and they said, well, I think this is not going to be big, so we are not going to be worried about that. And then like 1 or 2 years later, they said, whoa, a lot of people are using this is cool. What we can do about that? And then they say, whoa, we have our PaaS system, which is very good. The Azure PaaS, especially if you're working on .NET, is very good. And they say, okay, we have these app services here. We're going to use these app services here. But what happens is that the app service is a big thing. So in Azure, instead of you creating kind of just individual functions, what you create is a function app, which is a kind of container of some different functions. And then you deploy that to an app services. And then what it does, and then at the end, it's an app service, and some menus of the Azure portal, you will see the two things at the same time. And when you go to a function, you see the UI of the app service, so you can see some things about PHP, which you don't really care about, or the initial page of the app service, which you don't have. This is an API, I don't have any default HTML, and these kind of things. So they have to work more on the UI. And the thing is that they work on the app services, so a lot of functions apps are running at the same time there. And then when the app service it's full of, or they have no more resources, they start a new app services. Then they have less cold starts because you can run a lot of things in the same app service. But when you have a cold start, it hits you very hard. And you can be, I don't know, 4 or 5 seconds waiting for your application to start. And that's a problem. And then what they did to solve that is a kind of I've worked with .NET for a long time, and I quite like the guys and so on. But what they did is a kind of very Microsoft thing, which is, okay, we can warm up some app services for you, and we're going to bill you for those app services. So instead of solving the problem of the cold starts, they said, okay, we're billing you to solve the problem. Okay, thank you very much, guys. But that's the main difference. So in Azure is a kind of reuse of something that they have, and in AWS is a kind of brand new thing. I don't know how Google Cloud works, but my guess is that it's more like AWS than Micro.
Thank you.
Thank you, Vicenc, for your presentation. It was a nice set of criteria for evaluating serverless. Can you comment on the reliability, the cost, and the performance when used at large scale for applications that are completely developed serverless?
Yeah, so there's obviously a kind of latency, I wouldn't say problem, but if you work in a kind of a very performant financial application, latency can be a problem for you, so you shouldn't use serverless there. And then if you need fixed connections to something, you cannot use serverless because your thing goes down. And if you had a high and constant throughput of your system, you can use serverless, but it will cost you much more than if you use another solution. So they, at least AWS, they bill you for each 100 milliseconds of the function, and then they bill you depending on the memory of the function. The memory defines the machine that will run your container, and the cores that it will run, and then you will pay for the other services that you use. But one nice thing about that is that you can calculate quite accurately, with quite accurate, the cost of each request, because you will know how much I spend on Lambda, how much I spend on CloudWatch, how much I spend on SNS, whatever. And that brings kind of new possibilities for billing your customers or for knowing your business or whatever.
One of the objections I have read about serverless is that it's nice to build prototypes, but when you start having more traffic, it gets the progression to pricing builds up quite a lot, and then I think that the point they were making is that you should not choose serverless because it's free or because it's less expensive. Is that right in your experience?
Can you repeat, please?
Yeah, I hear a lot of arguments about using serverless because the first tier it's almost free. You said something like that, but what I understand is it picks up quite quickly when you start using it, and then it gets more expensive than dedicated.
So yeah, as I said, if you have a very high and constant throughput, it probably gets more expensive than another solution, and that is totally fair. So every case, I guess it's different. But one I think is very nice from serverless is that have something in production. You will not have a lot of, well, hopefully, if everything goes well, you're going to be there. But usually you don't have a lot of traffic the first day that you get off. So it's a very nice technology for startups because it allows you to be on production very, very fast, and then you can grow up without carrying out anything basically. And then if you are going to reach some problem, then you can do other things. But yes, it can be. Obviously, it can be more expensive, but if you don't, on the other hand, if you don't have traffic, it won't cost you anything. So, as usual in our industry, there are a lot of trade-offs, and obviously, it's not the silver bullet for everything serverless. But to me, at least, it will be my first option. I will think my thinking will be: there's any reason for I cannot do this with serverless? And if there's any reason, I will go for another thing. But by default, at least to me, and I'm very biased, and I'm not here, but to me will be the first solution. But obviously can become expensive depending on what you use.
Okay.
Well, cool.
That's it.
Thank you very much.
Thank you very much.